Hello friends, myself Hardik Patel. Up to last session, we have seen some basic concepts of multiple integral, change of variable, change into polar, and area by double integration. Now today, we are starting with the triple integration. Now first of all, in a triple integration, we are starting with a simple rectangular coordinate. That means we are starting with the coordinate system x, y, and z. Suppose you have given f is any surface with three variable x, y, z over a volume region capital V, then it can be evaluated by three successive integrals. Now in triple integration over volume V is denoted by triple integration V, f of x, y, z dv. Correct? Now, two types are there. As we have taken in a double integration, either limits are given or limits are not given. Suppose limits are given, then here see, you have given that evaluate from integration from 0 to 2, integration from 1 to z, and integration from 0 to y, z, x, y, z, dx, dy, dz. So, we are starting with the integration. So, first of all, see, here you have given y, z, correct? That means this is the limit of x. See, here it is already first integration is with respect to x. Now x is gone. You have two variable y and z. So here you have variable z. That means this is the limit of y. So here it is already dy. And the last limit is of z. So first you are going to integrate this term with respect to x. Okay. So first integration is with respect to x. So limit of x will be x square by 2, yz remains as it is, and limit from 0 to yz. And if you are going to put the limit, then you will have 1 by 2 constant common out, y square z square into yz dy dx. Okay. Now that will give you in double integration y cube z cube. So first you have to integrate with respect to y. So z cube common out and integration of y cube dy from 1 to z and 0 to 2. So integration of y cube is y raised to 4 by 4. Limit is from 1 to z. Correct? Now substitute the limit. So 1 by 2, 1 by 4 common out, and that will give you 1 by 8 integration from 0 to 2 z cube into c y raised to 4, that means limit is from z raised to 4 minus lower limit is 1, so minus 1. Now multiply this inside and integrate. So that will give you x z raised to 7 as an integration z raised to 8 by 8 minus z raised to 3 has an integration z raised to 4 by 4, and limit is from 0 to 2. So substitute the limit, that will give you 32 minus 4, and the answer will be 7 by 2. So this is the answer of your double integration. Please remember, you have to put the integration according to the limit. If the order is not maintained, here order is already maintained. In the case of you have all constant limit, then in that case you have to check out the integration with respect to dx, dy, dz, or dy, dz, dx, or dz, dy, dx. According to that you have to integrate, which we have taken is in double integration. Okay. Now, the second example we are going to take is triple integration in cylindrical coordinate system. Now see, in cylindrical coordinate system, we are going to use the coordinates r, theta, and z. So in cylindrical coordinate system, basically what we are going to do, we are going to reduce xy in a polar form and z remains z. Okay. So if you are going to consider the cylindrical system, then you have to put x is equal to r cos theta, y is equal to r sin theta, and z remains z. There is no change in z. Now, as we are changing the variable, so if you are going to change the variables, then in that case, your double integration, you have to also change the double integration. Sorry, triple integration. So in a triple integration, f of x, y, z, dx, dy, dz over any volume V is going to be a triple integration over a same volume V. There is no change in volume. F r cos theta, r sin theta, z into mod j dz dr d theta. See, z remains z, so there is no change in z. But dx dy is going to be changed. So if you are going to find the Jacobian, then the Jacobian of x, y, z with respect to new variable r, theta and z. And if you are going to find the Jacobian, then it will be r. See, Jacobian is basically find as we have find out in a double integration. First derivative of x with respect to r, derivative of x with respect to theta, and derivative of x with respect to z. Same manner for y, and same manner for z. Del z by del r, del z by del theta, and del z by del z. So if you are going to put the values, then this is going to be a cos theta, this is minus r sin theta 0, sin theta, cos theta, r cos theta 0, 0, 0, 1, and simplifying this, that will give you the r. Okay. So your double integration is going to be reduced in the form of double integration from double integration is going to be a mod j is going to be basically r, correct? So triple integration f of x, y, z, dx, dy, dz is going to be reduced in a form of triple integration f r cos theta, comma r sin theta, comma z into r dz, dr, d theta. Now you have to put the limits of z, r and theta according to as we have taken in double integration. Same manner here also we have to take the limits of r, theta and z. So first we are going to put the limits of z, and then we are going to take the projection, and then using projection we are going to put the limit in a r and theta form. Okay. So here we have taken the simple example. Evaluate integration from 0 to 1, 0 to root z, 0 to 2 pi, r square cos square theta into z square whole into r d theta dr dz. Now see, this limit is already defined. First limit is for theta, second limit is for r, and third limit is of z. Because here you have given the order d as theta dr dz, correct? Now, first integration is with respect to theta. So cos square is not directly integrable. So what we are going to do, we are going to write down cos square in a form of 1 plus cos 2 theta by 2. Now integrate this term with respect to theta. So that will give you integration r square as it is, this r as it is. So we are writing it inside. So 1 as an integration theta, 1 by 2 common out, cos 2 theta as integration sin 2 theta by 2, and z square as an integration z square theta. Limit is from 0 to 2 pi, correct? Now, once you have the limit, then put the limit. So here if you are going to substitute the limit, then you will have, this will be r cube by 3, sorry, r cube by 2 into theta. Theta is nothing but it is a 2 pi. Sin 4 pi has a value 0. So you will have r cube by 2 into 2 pi. Here plus z square into 2 pi. Okay. Minus 0, minus 0. So both terms are going to be 0. So 2 pi is common out from both the integration, both the terms. And you will have double integration from 0 to 1, 0 to root z, dr, dz. Now second integration is of r. So now integration with respect to r, that will be going to be a 2 pi into integration 0 to 1. R cube as integration r raised to 4 by 4 into 2, that will be 8, plus z square into r as integration r square by 2. Now limit is from root 0 to root z. Now substitute the limit. So that will give you root z raised to 4, that is z square by 8, and root z whole square, that will be a z. So z square into z, that will be z cube by 2. Integrating these terms, that will give z cube by 24 plus z raised to 4 by 8, and limit is from 0 to 1. Now put the limits. So that will be 1 by 4, 1 by 24 plus 1 by 8 minus 0. So taking LCM and simplify, that will give you the answer pi by 3. So this is the simple double integration. Sorry, triple integration in polar form. Now we are starting with the example where the limits is not given. Suppose you have given that triple integration over a region bounded by the curves surface is x square plus y square is equal to z square, z is equal to 0 and z is equal to 1. So here R is a region and you have to evaluate the triple integration under root of x square plus y square dv. Now dv is nothing but it is dx dy dz. So see, if you are going to start with the limits, then first of all, see, this is the curve in 3 dimensions. X square plus y square plus z square is the equation of a cone, infinite cone, and you are going to cut, you have a cone, infinite cone, and you are going to cut it by two parallel planes. Z is equal to 0, that means your xy plane, and the second parallel plane is z is equal to 1. So that will give you the cone of like ice cream cone you have. Such type of cone we have here. So this is the cone we have, and it is starting with a 0. And sorry. So we are starting with the cone. Then you have a cone like this in a 3 dimension, and this cone is starting from this point 0, 0, 0. This plane is z is equal to 0 plane, and here we are going to cut this plane, this region by this circle is z is equal to 1 plane. Okay, so if you are going to put the limits of z, first we are concerned with the limits of z, and the limits of z is starting from 0 and it is going to be end on 1. It is not like that. See, because your volume is bounded by 3 surfaces. First one is cone x square plus y square is equal to z square, and second one z is equal to 0 and z is equal to 1. So if you are going to consider the volume, then it will be the volume between your cone and the upper surface, correct? So whatever the volume contained by the cone, that is the inside part of the cone. Done? So if you are going to put the limit of z, then you have to draw the limit of z. For that we are going to draw one strip like this parallel to z axis. So it is starting from the cone and it is ending to the line z is equal to 1. So if you are going to put the limits, then it will be a z is starting from cone, that means z is equal to under root of x square plus y square, and it is ending to z is equal to 1. Now the limits of x and y, now projection is going to be a circle, and since the projection is circle, that means if you are going to check out what is the projection, that means if you are going from seeing the top of the region, then it will be a circle. Okay. So since it is a circle, that's why we are using the cylindrical coordinate. And we are going to reduce this in a form of cos theta and sin theta. So we are going to suppose that x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. So that's why your limit under root of x square plus y square is going to be r. This value is going to be r. And dx, dy, dz is going to be r, z, dr, d theta. Correct? Now, if you are going to put the limits, then z has a limit from under root of x square x square plus y square to 1. But x square plus y square is going to be r. So the limit of r is from, z is from r to 1. Now you have a whole circle. So limit of r will be from 0 to circle. Here this circle is x square plus y square is equal to 1 because you have cut it with z is equal to 1 plane. So you will have z is equal to 1 here. So this projection, if you are going to draw this projection, then this curve is x square plus y square is equal to 1. Correct? And since it is x square plus y square is equal to 1, so r square is equal to 1, that will give r is equal to 1. So radius varies from r is equal to 0 to r is equal to 1. And theta is going to be vary along four quadrants. That's why it is moving from 0 to 2 pi. Okay. So these are the limits. Now if your triple integration is going to be reduced in a form of triple integration under root x square plus y square dv, but under root x square plus y square is r, and dv, that is dx, dy, dz is going to replace with r, dz, dr, d theta. Now substitute the limits. So first limit is of z is starting with r ending to 1. Second limit is of r, it is starting with 0 ending to 1. Third limit is for theta, that is starting from 0 ending to 2 pi. So first integration is with respect to z. So double integration 0 to 2 pi, 0 to one r square constant and z, dz as the integration z, where limit is from r to 1, dr d theta. Now substitute the limit, so that will give you r square into 1 minus r. And now integration is with respect to r, so multiply r square inside and integrate r square minus r cube. So that will give you r raised to 3 by 3 minus r raised to 4 by 4, where limit is from 0 to 1. Now substitute the limit, that will give 1 by 3 minus 1 by 4 minus 0. Now 1 by 3 minus 1 by 4 is 1 by 12. 1 by 12 is constant common out. Okay, and integration 0 to 2 pi d theta. So d theta has an integration theta, and substitute the limit from 0 to 2 pi. That will give you the answer pi by 6. Correct? So in the case where you have not given the limits, you have to put the limits by yourself, and then you have to check whether it is directly integrable or it is easy to integrate. We are going to reduce the given integration in the form of spherical polar coordinates or spherical coordinates according cylindrical polar coordinates if it is not directly integrable. Okay, so these are the topics which we have covered in today's session. So if you have any query or any doubt regarding this topic, then please feel free to contact me. Thank you.